Hello students, I am Sonali Kelkar from City International School, and today we are going to do the third part of this chapter, Force and Laws of Motion. We are going to today the momentum and numericals, which are important from the point of view of exam. So let's start the session. Students, let's do a small recap first, right? Momentum. Now momentum, what is momentum? It is a product of mass and velocity, right? Now momentum is denoted by a letter P, right? Small p. Here P is a momentum, M stands for mass and V stands for velocity. What is the SI unit of momentum? Now before we make the SI unit of momentum, let's see what is the SI unit of mass. SI unit of mass is kg, right? So SI unit of mass is kg, so we'll write kg here. And what is SI unit of velocity? It is meter per second, right? So SI unit of momentum will be kg meter per second. Children, is it easy? Yes, I think it is easy. Now, change in momentum. What do we mean by change in momentum? Okay, a change in momentum is possible when a body was initially moving with a velocity u, right? And it started moving with a different velocity after a force is applied on it. That means there will be a change in momentum. Let's derive this. A body of mass m initially moving with a velocity u. So the initial momentum will be p1, right? And when body start moving, when a force is applied, it start moving with a different velocity. Let's take the other velocity as a final velocity, right? And the momentum will be p2 m into vp2. The change in momentum will be, it will be, let's take out mass outside, which is a common, and v, that is final velocity minus initial velocity. So the change in momentum will be m within the bracket v minus u. Children, this is very important from the point of view of numericals. So change in momentum will be m multiplied by v minus u, or you can write directly mv minus mu. Okay, so with both the formulas you can solve the numerical, right? Or you can write p2 minus p1. Simple, right? Now what is the rate of change of momentum? If this is a momentum, if momentum is m v minus u, now rate of change means there is a time, okay, which has come into the picture. Now it will be divided by t. The whole quantity is going to divide it by t. That means change in momentum in unit time. Simple, right? Newton's third law of motion. So we did Newton's third law of motion. Newton's third law of motion states that there is always a reaction for every action in opposite direction and of equal magnitude. It means action and reactions are the two forces which are acting on a two different body, but they are opposite in direction, having same magnitude. Simple it is. Now let's see the Newton's third law of motion, applications of Newton's third law of motion. Recoil of gun. Now what do we mean by recoil of gun? So when you fire a bullet from a gun, okay, when you fire a bullet which is coming out from a gun, what will happen? The bullet, okay, first the uh, gun is, okay, exerting force on bullet. So that is action, okay, I'll write A for action. Then when the bullet is moving very fast, it is moving very fast, right? Okay, it is moving very fast. This is the bullet is also exerting force on gun, right? That is a reaction, right? In both the cases, action and reaction are equal. The only thing is that the force which is acting on gun, you cannot realize that much of force. It is a jerk that you realize, okay, little bit of jerk that you realize, because the mass of bullet is much. So the force has balanced, right? Now, walking of a person able to walk due to the Newton's third law of motion. We have already discussed this, because if a person exert force with his leg, exert force on the ground is also exert force on the person. The force exerted by the person on the ground will be action, right? And the force exerted by ground on the person will be reaction. And due to this reaction, a person can able to walk on the he can walk forward on the ground. Swimming of water, okay, in this case also, when a person is swimming in water, right, okay, you are exerting force and you are removing some water, okay, you are pushing the water, you pushing water, and because of that push, the water is also exerting force on you, right? If this is a person, okay, he is swimming, fine, so he is exerting force on water, that is action, and as a result, water also exert force on person, that is reaction. Okay, so action and reaction. Okay, because of this a swimmer can swim. Propulsion of boat in forward direction. Here also, when a sailor pushes water with roar in backward direction, resulting water pushing the roar in forward direction. If with the help of a roar, if the sailor is pushing water in the backward direction, so okay, so the action taken by the row, it will be considered A, right? And as a result, water also exert force on the row, and as a result, the boat will go in a forward direction, right? So that is a reaction. Fine. So in all these cases, you have seen that there are always a two object. Okay, there are always a two object, and the forces acting on both the object, equal forces acting on both the object, but see the direction. Direction is always different, right? Direction is always different. So opposite direction, you can say, right? So this is all about recap. Now let's do the conservation of momentum. Okay, now what do you mean by the word conservation? Okay, that means there is no loss of any quantity. It is conserved, it is preserved. Okay, and the quantity here, what we are talking about is momentum, right? Now what is momentum? We all know it is a product of mass and velocity, right? So conservation of momentum, it is based on the Newton's third law, right? It is based on the Newton's third law of motion. According to this law, total momentum of a system of an object remains same. Okay, according to this law, the total momentum of the system of an object remains conserved before and after the collision, provided that there is no external unbalanced force acting on them. So total momentum before the collision and total momentum after the collision remains same. Now let me explain this, right? Suppose a car, there are two cars, right, moving on a road. Fine. One is a small car, the other one is a bigger car. Clear? They are moving on the road, a straight line, right? The velocity of the small car, let's take the mass of small car is m, and the velocity of this car is, let's say, u, and this velocity is velocity of the car u is less than the velocity of the car this. So let's take the mass of the small car m1 and u1, and mass of the bigger car as m2 and u2, right? Here the smaller car is moving with the greater speed, the speed. Okay, so the speed, let's take speed of a small car is greater than the speed of your bigger car, right? Bigger car. So let's take v1 is greater than v2, right? So what will happen after some time? Let's see that they have collided with each other. Okay, they have collided, right? Okay, here they have collided, and after some time, of course, after the collision, they went in a different direction. There was a change in a speed. Now, because there is a change in the speed, there won't be any change in mass. Though definitely the momentum, okay, after the collision will be different. So let's see first what will be the speed? So speed of the small car m1 v1 and the speed of the bigger car after the collision m2 v2, right? So what according to the law, what does the law say? That the total momentum, okay, now what is the total momentum in this case? Definitely m1 u1 plus m2 u2, right? Momentum of both the car, okay? So m1 u1 plus m2 u2, isn't it? This is the total momentum of both the car. Total momentum before collision, see, before collision is equals to total momentum after collision. Now what is the total momentum after collision? That is m1 v1 plus m2 v2, right? So this is what the law says, right? Now what do you understand by there is no external unbalanced force, right? These system which we have taken here, they are isolated system. Isolated system means this car is going, the other car is going to bang this, okay? After bang, these will get separate, okay? So in this case there is no other force which is acting on this car, right? It might possible that during this case, during the collision of these two cars, it might possible there is a third car which will, or the third scooter, okay, a person, okay, a cart can also collide with them. In that case, okay, in the case where there is a third or some other external force applying on this car, then the conservation of momentum won't take place, right? So it is only in the isolated system it takes place. Children, I hope you understood. Okay, now let's do the mathematical formulation of this uh, law of conservation of momentum. Okay, children, suppose the two object A and B. Suppose the two object A and B, each of mass m1 and m2. Here are the two object m1 and m2 are the mass of the object, right? Okay. Now initial velocity of m1 is u1, initial velocity of m2 is u2, right? Now what will be the momentum of A? Definitely it will be m1 into u1. Now what will be the momentum of B? It will be m2 into u2. Is it initial momentum before the collision or after the collision? Yes, it is a total momentum before the collision, right? Now let's collision taken place, right? After the collision, what happened? These two objects, okay, they started moving to a different direction with different speed, right? So that will be the final speed. Now let's find out the momentum of A and B at this time after the collision, right? So m1 v1 momentum of A and momentum of B is m2 v2, right? So this is what is a total momentum before the collision and total momentum after the collision, right? Now because we have to derive this equation mathematically, let's see how you are going to derive, right? So first what you have to take is rate of change of momentum, right? Rate of change of momentum is equals to change in momentum divided by time taken. Okay, now here is change in momentum. Now change in momentum when object A, okay, collides with B. Change in momentum when object A collides with B will be m1 v1 minus m2 v2 divided by t, right? m1 v1 was the final momentum of object A. m2 u2 is the initial momentum of object A. Because we have to find out the rate of change of momentum, we have to divide by t, right? Now because m is common, I can take out m1 outside. The quantity which you are getting is v1 minus u1 divided by t. Clear? Right. Now let us take the second object, okay? And when the force acted on the object, when the force is acting on object A by object B, then in this case m2 u2 m2 v2 minus m2 u2 divided by t. Now what is m2 v2? M2 v2 is the final momentum of object B, okay, initial momentum of object B divided by time, and then we will get m2 outside, you have to put v2 minus u2 divided by t. So we are getting two different equations, right, here. But for the Newton's third law of motion, from the Newton's third law of motion, we know that the force act on the two different objects are equal, but they are opposite in direction. So the force act by the object A on object B is taken as m1 v1 minus u1 divided by t, right. Now the force acted by object B on object A, I have to consider this force as negative force. Why? Because we know that this force in the opposite direction, right, the two forces acting in a opposite direction, right. So the force, this is in this direction and this is in the opposite direction. So because of this I have taken minus. F is force acted by B on A, right students. Now you have to substitute this value over here. Okay, so you have to substitute the rate of change of momentum of uh, the A or rate of change of momentum when the body A act force on B, and rate of change of momentum when body B acts force on A. So I have substituted the value here, right. Now over here you can see that there is a negative sign outside, right. So because of this, this m will become negative, right. Now let's multiply minus m2 with v2. I am getting minus m2 v2, isn't it? Negative multiplied by the positive sign, so it will be a negative. Now minus m2 multiplied by u2 minus m2 multiplied by minus u2, so it will be plus m2 u2. So I am getting minus m2 v2 plus m2 u2 here, right. Over here also we have multiply minus m into v1 is m v1, and m into minus u1, m into minus u1 is equals to minus m1 u1. Now because the t is common on both the sides, so I can just cross the t, right. So what happened, now we have to shuffle, right. So let's take this minus m1 u1 over here, so that I will get the plus m1 u1 here we have shuffled, and minus m2 v2 on the left hand side. So I got m2 v2 plus m2 v2. Now final statement, look at the final statement. Now this is my total momentum before the collision, and this is the total momentum after the collision, right. Okay, so here it is proved that the initial momentum and the total initial momentum and the total final momentum is equal. So this is how we have proved mathematically that the initial momentum, total initial momentum and the total final momentum of a isolated system is equal, they are equal. Okay, now let's do the application of conservation of momentum. First one, the propelling of rocket. What happened when the rocket uh, propel? Okay, what happened inside the rocket? There are so many chemicals, right? These chemicals, they burn and they come out with a great force. Okay, they come out with a great force, and because of the great velocity, the momentum is very high, right. Okay, so this and this force is exerting on the rocket also, right. This force is exerting on the rocket also. When this force exerts on the rocket, rocket also starts moving. Okay, why this force is exerting equal and opposite force exert on rocket? Because there should be a conservation of total momentum of gases, right. So that is why this this particular system of a rocket and the gas, which is an isolated system, right. In this system there is a conservation of momentum of gases. Okay, so let's take the another example, flight of jet planes. Okay, flight of jet planes, a large volume of gas produces by the combustion of fuel is allowed to escape through a jet in a backward direction. So this fuel is moving in a backward direction, right? So there is a great momentum produced because of the great velocity, right? And definitely this momentum is going to give effect to the plane also, and because of the opposite force which is acting by this escape gas on the plane start moving, and there is a conservation of momentum, okay, in this system. The plane gets pushed in a forward direction and moves with a great speed. Why? Because there should be a conservation of momentum. These two are also an example of action and reaction, because we have already proved that the conservation of momentum is basically based on the third law, that is every action has equal and opposite reaction, okay, and the force between the two action and reaction, the magnitude of force is same. Right, now let's do few questions, children. Okay, which of the following has more inertia, a rubber ball and a stone of the same size? A stone, definitely, because rubber ball will be lighter as compared to the stone. And what about the inertia? Inertia, the measurement of inertia is what? The measurement of inertia is mass. Inertia depends upon mass. So in these options, whichever body has more mass will have more inertia. A bicycle and a train, very obviously it is a train because train has more mass. 5 rupees coin and a 1 rupee coin. So 5 rupee coin will have more mass as compared to 1 rupee coin. So 5 rupee coin will have more inertia. Okay, it will have more inertia, train will have more inertia, rubber ball will have, stone will have more inertia, because all three of them have great mass as compared to the other. So let's see the answer. Yes, you can note down these answers, children. Question number 2, explain why some of the leaves may get detached from a tree if we vigorously shake the branch. See, if you vigorously shake the branch, what happens? The leaves want to retain in a state of rest, but you are shaking the branch, right? So because of that force, the leaves get detached from the branch and they fell off. Here, the answer, when the tree's branch is shaken vigorously, the branch attains motion, but the leaves starts at rest. Due to the inertia of rest, the leaves tend to remain in its position and hence detaches from the tree to fall down. Okay, if action is always equal to the reaction, explain how a horse can pull a cart, right? When horse is pulling a cart, definitely the horse is exerting force on the ground, right? Horse is exerting force on the ground. I won't draw the horse, but I'll just draw legs, right? Okay, horse is exerting force on the ground. Because of the force exerted by the horse leg on the ground, definitely he is going forward, because ground is also exerting equal and opposite force on the horse, and because of that the horse can pull the cart, right, students? So you can see the question answer here. Right, here's the answer. You can note down the answer in your copy, right? Let's go to the next question. Explain why is it difficult for a fireman to hold a hose, okay, which ejects a large amount of water at a high velocity. Can you say that this is related with momentum? We can say that. Yes, we can say when a large amount of water, that means it has great mass and even moving out with a high velocity, that means it has great velocity. So definitely the momentum of that water will be the great. It will be very great, right? And of course, to balance the momentum, because the total momentum of a system should equals to the final momentum. The total initial momentum equals to the total final momentum, right? So that momentum has to be get balanced. So even water exerts a force on hose, and because of that it's very difficult for a fireman to hold that pipe. Okay, so let's see the answer. Right, so this is the answer that you can note down in your copy, children, and you have to write all the question answers in your copy. Coming to the next, this is a numerical. Okay, question number 5. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with the initial velocity of 35 meter per second. Calculate the initial recoil velocity of rifle. So what formula we are going to use here? Okay, what is the formula? We know that the momentum of the bullet should equals to the momentum of the rifle, right? So momentum of the bullet should be equal to the momentum of rifle, right? Let's take the mass. Okay, the rifle of a mass 4 kg. So I will take the rifle mass, that is M1. I will consider as M1 because it is given first, so you can consider it as M1. M1 is 4 kg, right? Okay, and what about mass of the bullet? Mass of the bullet I'll consider as M2, right? Bullet mass M2 50 grams. So you immediately what you have to do, because it is given in gram is not a SI unit of mass, convert into kg. So 50 divided by, children, what should be 50 divided by 1000? So when you divide 50 by 1000, what will be the answer? Okay, is it 0.05? Is it 0.05 kg? Right, it is 0.05 kg rho. Okay, fine, done. So what about the momentum of the rifle? For finding out the momentum of the rifle, I have got mass, and do I have velocity? No, we don't have velocity. Okay, so that we have to find out. So we have to find out V1, that is a recoil velocity. In fact, it is a recoil velocity. Okay, so that we have to find out. So just put a question mark over here. Then what is the velocity of the bullet? That is V2. Velocity of the bullet is 35 meter per second. 35 meter per second. Children, I want you all to do calculation very fast. Now this momentum of your rifle should be equal to the momentum of your bullet, right? So I have taken the momentum right here. The momentum of rifle should be equal to the momentum of bullet. So I can write m, what is the momentum? M1 into V1, isn't it? This is the momentum of rifle equals to the momentum of bullet, m2 into v2. Okay, you can put multiplication sign v2. m1 is 4 into v1, m2 is 50 into 35, right? So keep your v1 on the left hand side. This is the variable. 50 into 35 divided by 4, right? So when 4 will come on this side, definitely it will going to divide this quantity 4. So what is the answer we are getting? What is, okay, okay, this is 50, this should be 0.05. Oh, so this should be 0.05, 0.05, right? 2 minutes, children, I'll just raise. Okay, this mass should be 0.05. Okay, mass of the bullet is 0.05 and V2 is 35. Okay, okay, so when I multiply 0.05 with 35, I am getting 1.75. What is 35 into 5? 35 into 5 is 175. After the point there are two numbers, so after the point there should be two numbers, so 1.75, right? Okay, this should be divided by 4, so you can directly write 4 here. So if I divide this by 4, I am getting 0.44 as 16, right? So 0.4, I can take then 3, and then it is coming 7. So I think you can stop here. After the decimal, make sure that you write two numbers after the decimal. That is compulsory, right? 0.4375 is also 0.4375. It is coming, but even if you write 0.43, that is perfectly what should be the unit here. Unit of velocity is meter per second. So don't forget to write unit meter per second. So this is your final answer, right? This is the answer. Okay. So written. I will just rub what I have written. Okay, so you can copy this answer from here. I have cleaned for you all, right? Let's take up the next question. Yeah, here is the next question. A hockey ball of mass 200 gram traveling at 10 meter per second stuck to a hockey stick so as to return it along its original path with a velocity of 5 meter per second, right? Okay, and calculate the change in momentum occurred in the motion of a hockey ball by the force applied by a hockey stick. Here, children, the mass of the ball is given in gram, so you need to change it into kg, right? So let's start. So let me demonstrate this question first, right? A hockey ball of mass 200 gram. Okay, let's make a hockey ball, right? It is traveling with a velocity 10 meter per second. So this will be the definitely initial velocity. Weight, let's see, the weight is 200 grams. So I need to change this weight 200 gram into kg. So right, I'll divide 200 gram with 1000. So uh, what will be the mass in kg? Definitely it is 0.2 kg, right? So the ball of mass, okay, this is mass of a ball. Okay, mass of a ball is 0.2 kg traveling with 10 meter per second. Okay, this is my initial velocity, right? 10 meter per second. So I don't have to make any changes here. It's stuck by a hockey stick. Okay, let me draw a hockey stick here. Okay, it is approximately right. Okay, it got struck by hockey over here, and then what happened? It returned it along its original path. In the same path it was returning back. So because there is a change in direction, you can see the direction are opposite to each other. So the final velocity, that is v, will be -5. Why it is -5? Why I have taken -5? I'll write meter per second later on. Why I have taken -5? Because the direction of the velocity has changed, and velocity is a vector unit. So definitely we have to consider the directions, right, student? So now let's do the calculation. They have asked change in momentum. We all know that change in momentum. What is a change in momentum? Change in momentum. I'll write the short form, okay, in momentum. Change in momentum, I'll write small p. Change in momentum will be p2 minus p1, or let's say here mv minus mu, where m is 0.2 mass of a ball, right? Within the bracket v. Now over here v is -5. So -5, and minus sign is already there. Minus. What is u? 10. Right? It is 10. Now if you solve this, -5 and -10 is 0.2 into, what is -5 minus 10? -15, right? Okay, so what is 15 into 2? 30. But there is a point here, so I'll put a point, right? And the negative sign is also there. I can't avoid it, so it has to be -3. So it is -3. What is the unit of momentum? Kg, meter per second. Okay, so this is what ms minus 1. So this is the final answer, children. Okay, so I'll just rub it so that you can write the proper answer. After this, the answer will come to your screen and you can write it down in your copy. Okay, it is very essential for you to understand the solution, how to do the solution, and then you can note down. Here's the solution. Okay. Okay, so let's do the next. Here student, question number 7, a object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. Now calculate the initial and final momentum of the object. Also find the magnitude of the force exerted on the object. Okay, so let's start the solution of this question. So let's solve this question, right? So let me take my pen, right? Okay, body object of mass 100 kg. So mass is given 100 kg, right? 100 kg. Okay, fine. An object, let me make and draw an object. Object is accelerated. Accelerated means there is a change in velocity, right? M is 100 kg. Okay, so the initial velocity was 5. It is 5 meter per second, and later on the velocity has increased to 8 meter per second, and the time taken is 6 seconds. Okay, so you have to find out, okay, from here to here 100 kg. Right, so we have to find out this momentum and this momentum, initial momentum. So let's straight away find out the initial momentum. Let's make that initial momentum as P1. We know that P1 is m into u, right? Substitute the value 100 into 5. So we are getting 500 kg meter per second, kg meter per second, right student? Fine. Now P2, m into v, m is 100, isn't it? And v is 8, so we are getting P2 as 800 kg meter per second, right? Now in the second case we have to find force. Now we all know that force, sorry, okay, force, I'll write here, force is equals to mass into acceleration, right? F is equals to mass into acceleration, right? So mass, we know that 100, and acceleration is v minus u upon t, right? So just substitute the value 100. What is v? 8. V is final velocity, 8. Initial velocity was 5. So let me okay, raise it. I'll erase this. I'll make it 5. Okay, 5. 5 divided by time. They are given 6 seconds. So 6 seconds, right? What was 8 minus 5? 3. 3 into 100, children, 300. 300 divided by 6 is what? 50. And what should the unit, what should be the unit here, because we are finding out force? What is the unit of force? Right, Newton. So 50 Newton is the force applied, right? So let's do the next question. Before that, I'll just clean the screen so that you can write the answers in your copy. Okay, so whenever you write solve numerical, you first write down the given and then you can straight away make changes in the unit if it is required, and calculate the sum according to the formula. Let's do the next question. This is the uh, solution of the same question. You can note down the solution. Okay, question number 8. A motor car of mass 1200 kg is moving along a straight line with uniform velocity of 90 km per hour. Its velocity is slowed down to 18 km per hour in 5 seconds by an unbalanced external force. Calculate the acceleration and change in momentum. Also calculate the magnitude of the force required. Now let's do this question. A motor car of 1200 kg. So this is what is mass, right? That is 1200 kg. On a straight line it is moving, but the initial velocity was 90 km per hour. You need to change immediately into meter per second, and here the velocity, the final velocity is V is 18. So there is a deceleration, that is the velocity is decreasing from 90 to 18. Okay, mass here I will be considering same, that is 1200 kg, because the mass is given in kg, so you don't have to do any conversion in mass, right? So but you need to do the conversion with initial velocity. So 90, you have to change meter per second, multiply by 5 upon 18. So 90 will go with 18 by 5. So 5 into 5, you will get 25 meter per second is the initial speed, and here 18 multiply by 5 upon 18. So the 18 will get cancelled. Here you will get 5 meter per second answer, right? Now what we have to find next, calculate the acceleration and change in momentum. Okay, so let's calculate the acceleration and change in momentum. What is the formula of acceleration? Acceleration is A is equals to V minus U upon T. This is the formula of acceleration. What is V here? Final velocity is 5. So 5 minus initial velocity is 25 divided by the time. So the time here is 4 seconds. Here we have to write 4 seconds is time taken. 4 seconds is the time here. So you can write in this diagram 4 seconds, right? Okay. So 20, this answer will be minus 20, minus 25, and 5 will be minus 20 divided by 4. So you will get minus 5. So acceleration is coming minus 5, right? So now you have to find out change in momentum. So change in momentum will be, okay, P will be mass V minus U. This is the formula of change in momentum, isn't it? The mass is 1200 and V minus U. V is 5 minus 25, that is minus 20. 5 minus 25 is minus 20, minus 20 into 1200. The answer will be, what is 20 into 1200? 24 minus 24,000, right? Minus 24,000 kg meter per second should be the unit, right? So we found out change in momentum. We found out acceleration and also calculate the magnitude of the force. So force is what? Force is equals to same. Force is equals to mass into acceleration, and mass is this, acceleration is v minus u divided by t. So we have got v minus u, we have got minus 24, that is a change in momentum. We can directly substitute the value, minus 24,000 divided by t. T is what? 4, right? So this, the answer will be minus 6,000 Newton. Fine, student. So this is all we did in this question. I'll clean the screen and the answer will be shown to you after this. And this is the end of the session. Okay, here is the answer, children. You can note down this answer in your copy. And this is the end of the session. Practice today's topic. Thank you so much.